Welcome to Help, I'm Stuck on 5D, as in David, standard form equations. So I'm going to talk a little bit about the standard form. So here we have a very basic structure of the standard form. There's some letter A, that's a constant. That means just a number. And formally we call this a coefficient. So AX plus BY equals C. So A, B, and C are all just numbers. X and Y are variables, and they need to be in there. We have some special names for these letters. So this is the coefficient of X, which means it's the number that's multiplied by X. This is the coefficient of Y, which means it is a number that is multiplied by Y. And this is called the constant coefficient because it's just a number standing by itself. You'll sometimes see this structured as AX plus BY minus C equals 0. That is called the general form, which is just a rearrangement of the standard form. But the standard form is particularly useful for situations where you might have a couple of products that add up, or the difference of them is some fixed value. So if I have miles per hour times some unknown hours and miles, a different number of miles per hour plus another times another set. Let me start that over here. I have miles per hour. Let's say I have 40 miles per hour times an unknown amount of time plus miles per hour times a different miles per hour times another unknown amount of time. And then this here would be a distance. Miles speed times time is distance. Speed times the other time, different speed times the different time would also be a distance. And two distances together could equal a distance. Or this could be a price per pound, and X could be the number of pounds. This could be a different price per pound, and this Y could be an unknown number of pounds of a second thing. Okay, and then price per pound times pounds is price overall, and price per pound times pounds would be price overall. And so we could add those two overall prices to the amount, and C would be the total amount of money being spent. Those are a couple of ways this could play out. You will be using the standard form a fair amount in the next unit in systems of equations, so it's really important to be familiar with it. And you'll need to learn how to work with it for word problems, because we'll be applying this in word problems in the systems of equations unit, as well as level 6 from linear. So let's actually look in Desmos at how this works. So if we've got AX plus BY equals C, you can actually work out some things. So first thing, a couple things. So A should generally be non-negative, so it should be positive. B shouldn't be 0, otherwise it's a vertical line. And C can be positive or negative, or 0 if you want. Officially, A, B, and C are supposed to be integers, but this will work if they're not. So don't worry too much about that. What I'm going to do now is I'm going to find the X-intercept. The X-intercept is going to be, and this is one of the great utilities of this line form. I'm going to change this. I'll change that to 4. I'll change that to 5, and I'll change this to 40. And I'll move this over so you can see them. Okay, so you can see already that the X-intercept is 10, and you can see already that the Y-intercept is 8 right there. So you can see those things. But let's actually see how you could calculate it, and this will lead to a cheat code. And this is where this video should be particularly helpful for you. If I'm trying to find the X-intercept, I'm going to set Y to equal 0, which means B times Y is going to be nothing. So all I'm going to care about is AX plus C. I'm sorry, equals C, because that B ended up being multiplied times 0. And who cares about that? Go away. So now we just have to solve for X. Well, X is just going to be C over A. If I divide both sides by A, I'll end up with C over A. So I actually can use these coefficients, these numbers that are multiplied by X and Y, and this standalone one, this constant coefficient over here. I can use those to come up with the X and Y-intercept. So there it is, 10, 0. There's my X-intercept. Then I can also find a Y-intercept. And the Y-intercept X is 0. So I can go in here and say A times 0 plus B times Y equals C. And I don't care about A times 0. So I can just delete it. And so now I've got B, Y equals C. So Y is going to be C over B because I divide both sides by B to get rid of times B. And Y will be by itself and it'll equal C over B. So there I have a cheat code for the X and Y intercepts for a standard form line. Now I can move these around. The point will stay where it is, stays just fine. Let me clean some things up so they're not distracting. So no matter what I make A and B equal, those intercepts stay there. I can change the C value and so forth. So this C over B will get you the Y-intercept, and C over A will get you the X-intercept. So it's really useful when you're trying to graph things because you just plot a couple of points and draw a line through them. Of course, sometimes you might need the slope from the standard form, and the slope is going to be the change of Y over the change of X. So I'm going to set up my slope equation. It's going to be change of Y, so I'll also do 0 minus C over B. And this looks like, oh my goodness, it's going to be really annoying. It actually isn't going to be. My change in X is going to be C over A minus 0. And so I'm just setting up a generalization. I don't care about minus 0. 0 minus this means that's negative. I can move that negative out in front of the whole thing, so I'm not worrying about that. Now, this fraction bar means division. I'm doing C over B divided by C over A. So I'm going to put the negative out here, and I'm going to say C over B, and then that's divided by C over A. And if you remember your keep, change, flip, I'm going to keep, then I'm going to change the division to multiplication, and then I'm going to flip my divisor. C over A becomes A over C. And now I can put things together. I've got negative. My numerators are going to multiply times each other. CA. That's going to be over BC, because the denominators will multiply. And now if you might notice that the numerator and the denominator both share a common factor, which can be factored out. C goes out, C goes out, and I now have my slope. My slope is going to be negative A over B. So all I have to do to get the slope from a standard form equation is say A over B and take the opposite of that. Now I'll give some examples now really quickly. I'm going to give you an example. 4x plus 3y equals 24. And all I have to do to find the x-intercept is do 24 divided by 4. That's the C over A. And so the x-intercept is going to be 6. And there it is. It's 6. To get the y-intercept, I do C over B. And 24 divided by 3 is 8. So there's my y-intercept, and it is at 0, 8. To get the slope, I say negative A over B. So negative A over B is going to be negative of 4 over 3. That'll be my slope. And now just to demonstrate that that actually is legit the same line, I'm going to turn this into a slope-intercept form. Since I know my slope, I can say y equals 4/3 x. And then I can add my y-intercept. My y-intercept was 8, so plus 8. And if I turn that line off, this one is the same thing as this one. They're the same line. And so I have found the slope. Okay, I found the y-intercept. I found the x-intercept. So x-intercept was 6, 0, because that's 24 divided by 4. The y-intercept is 0, 8, because 24 divided by 3 is 8. And my slope was negative of A over B. All right, I hope this helped. Please let me know if you would like some further information on that.